Mostly what we've done so far with trig has been revisionary in nature, but also two-unit level. 3D trig, although you've seen 3D trig before, but this is extension only. So you're not going to get 3D trig questions in a two-unit paper. Now, when dealing with 3D trig, I often find it handy to redraw the triangles in 2 dimensions, because sometimes those diagrams can be deceptive and you start seeing angles that aren't really there and things like that. So sometimes I find that handy. So let's look at, it's quite an old question now, but a typical sort of 3D trig question. So David's in a life raft, Anna's in a cabin cruiser searching for him. Fortunately, they've both got mobile phones. Technology's wonderful. David tells Anna, who all of a sudden has spelled her name differently, that he can see from Mount Hope. He can see Mount Hope's over there. And fortunately, he also happens to have one of those, like sextants. That's the word I'm looking for. Sextants, so he can look at the bearing and he can work out, okay, from David's position, that it's got a bearing of 109 degrees. So if ever you're in a raft, make sure you have these things with you. A mobile phone, a sextant, a compass, all these sorts of things. And the angle of elevation is 16 degrees. But Anna, fortunately, she also can see the same mountain. And from her position, it's a bearing of 139, and top of the mountain, angle of elevation of 23. So what we're looking at here is one of those real-world problems. The top of Mount Hope is 1,500 metres above sea level. We've got to find the distance and the bearing of the life raft. And they gave us this lovely picture. Apparently, that's a cabin cruiser. Huge cabin cruiser, tiny little raft down there. All right. So I'm going to redraw all different triangles, make life easier for myself. So I've got triangle HDB, and I know a side and an angle in that one. I've got triangle HAB, again we know a side and an angle. Then if I look down on the ground, okay, so we know the bearing from David to the base, which they've labelled B. We know that bearing's 109. We know Anna, her bearing's 139. So this creates another triangle. We join that up. We basically want to find the length, and I've labelled it little b because it's opposite capital B, but also this angle, the bearing, so this whole green angle there. They're the two things we're trying to find. Okay, well, I can get an expression for BD, 1500 tan 74. So we can calculate what that's going to be. I can also get an expression for AB. So going back to our diagram, we'll label those. So we've got two sides of that triangle down there. We need to find a third side. So really now, all I need is one angle, at least. Then we could use the cosine rule. If I got two angles, I could use a sine rule. So what angles do we know? We've got 139 up there. We've got 109. Our norths are obviously parallel to each other. We should be able to work it out. If I draw in a third north over here at B, so it'll also be parallel. So I've labelled it N with 2 dashes there. Okay, bit of geometry. I know that NDB and DBN double dash will be 180 because of co-interior angles. That'll end up meaning DBN 71, or DBN double dash is 71. And by a similar method, I could work out ABN double dash is 41. Okay. Now, ABD as DBN minus ABN, basically it's the same angle. I'm just expressing it in a different way. So ABD is 30. So subbing that in, that's really the angle I want, is that 30 degrees there, because now I've got a classic cosine rule question where I can find little b. So little b squared will be 1500 squared tan squared 67, 1500 squared tan squared 74 minus 2 times 1500 tan 67, 1500 tan 74 cos 30. Bung that all in the calculator, find the square root of it to the nearest metre. We get 2,799. So now we know how far apart they are. But remember, there were two parts to this question. We also got to find the bearing. Okay, back to our diagram. So I've labelled that theta. The big green angle we're trying to find is theta. Now, we know this blue one here is 139. So all I've got to do is find this angle BAD, and we'll have the bearing. So BAD, I've now got three sides at an angle, so it should be relatively simple to find. So I use the sine rule for that one. Sine DAB over what we found to be 1500 tan 74 will be sine 30 over what we've just worked out to be little b. Playing around with all that. Okay, two possibilities, of course, with the sine rule. 69 degrees 9 or 110 degrees 51. So the question is it acute or is it obtuse? What's going to make sense in our question? Now, if it turns out that it's 69, so if I use the, I guess, the one we'd all assume, the acute angle, that angle BDA will turn out to be 80 degrees 51. But what I do know, I haven't got it up here, but if you have a look at the diagram, angle DAB has got to be bigger than BDA. So therefore it must be the obtuse one, can't be the acute one. So we now know that one's 110.51. I can add it to the 139 and we get our bearing, 249.51. Oh, let's try another one. Again, a triangular pyramid. Essentially, I mean the last one also was a triangular pyramid if you look at it, the way it was. Surveyor is standing on point A, due south OT. Angle of elevation is 45. They then walk a further 100 metres. Angle of elevation is now 30. Bit of a gift mark to start off with. Express the length of OB in terms of H. So if we look at that triangle that has OBT, we know that angle's 30, we know that's H. So OB over H is tan 60. OB is H tan 60. Some people would have gone cot 30, only because the angle given was 30. I suppose it doesn't really matter. Same thing, of course, tan 60, cot 30. All right, second part of the question. Show that H is 50 root 2. All right, if I look at one of the other triangles, that was 45 degrees. Well, a right angled triangle with 45 degrees is, of course, isosceles. So ATO is isosceles, so that means AO is also H. Now if I look at that triangle, ABO, we just found OB was H tan 60. We're told AB is 100. Bit of Pythagoras. And of course tan 60 is root 3. Square it, we get 3. 2h squared is 100 squared. 100 on root 2. Notice little things like this. I didn't bother squaring the 100 because I knew later on I was going to find the square root of it. So I just left it as 100 squared. It just saves time with things like that. 50 root 2. Oh, the bearing. Calculate the bearing from the base of the tower. Okay, so if we look down on our problem, put the compass at O, because it's the bearing from the base of the tower. B's over there. We've worked out that to be 100, that to be 5 root 2. It's a right angled triangle. Should be fairly straightforward, but of course I'm going to have to find AOB first. Then subtract it from 180. We've got our bearing. Whoop, that's the one we want to find. So AOB, 100 on 50 root 2, 54.44. So our bearing, 125.16. Okay, so we've got two exercises there.